I think okay. I was calling him Parth throughout, so I remember he is Arman. I remember
I am right.
again another. Okay. You were there last. What I should write? Tell me what all we did last time because I'm a bit confused.
We did unicellular and multicellular difference. And multicellular difference. This is physics.
Yeah.
Ma'am, distance and
Now you're
distance.
confusing me as biology teacher.
Ma'am, speed, velocity, graphs.
Is it speed velocity graph?
Yes.
Okay. And did we do acceleration in last class? No.
Sorry.
Did we do acceleration in last class? Can I see some of your questions which are done? Like if you have drawn something like this.
No, you didn't hear it yet.
Okay. All right. So we are doing motion chapter, and we have done distance, displacement, and you're saying you have done velocity as well, right? We have done velocity as well. Raman, can you tell them also and me too what is velocity?
Displacement.
It is displacement. Like why will I have another name for displacement?
It is displacement plus direction. No, sorry. It's displacement plus something.
Okay, Arman. Can you tell me what is displacement then at least?
Yeah.
Tell me what is displacement.
The point starting from initial position to the ending position is called displacement. Where you start and end.
I started and okay. Anirudh, can you add to that because we have been doing distance and displacement all the time and still Arman, I am not able to get clearly what you are trying to say.
Ma'am, distance is the path traveled by an object and displacement is the change in position from a body.
Yeah, change in position from the initial position. So in case I am moving here to Arman, like I am moving from here to Arman. If I go like this and then reach Arman, so then what is my distance? It is whatever path I take. If that is distance. Whole path measurement I will do and I will say that is distance. But when I say what is displacement, then I move from here to there. So what is change in position? I don't see what path I take, whether this, that, or whatever. But this is first position, this is initial position, and that is final position. So this change from here to here, what is the shortest distance between me and Arman? I just draw a straight line. Okay, will I take all this whatever long cut I took? That is taken when I'm calculating distance covered. But what is displacement? Just the shortest path between initial and final position. Okay. Velocity and speed. As far I remember, we did in-depth of difference between velocity and speed as well. So although Arman was not able to tell the difference, but at least we know what is this difference between distance and displacement. Anirudh, can you tell what is velocity? Because velocity is not certainly displacement. We cannot have heard name for. Right. So what is velocity? Formula.
And formula.
Okay, tell me what is formula for speed and velocity? You know
Distance upon time.
for this one. What is formula for this one?
And meter per seconds.
Okay, I'll give you hint since we have done. This is distance. This is time. We call that as speed. Okay, what is ms?
Meter
Meter per second. Okay, unit is meter per second. Okay, that is unit. Over here, velocity is also something upon
Initial
time.
velocity is minus
Yes. No, that is something else called acceleration. So we have just had velocity. What is velocity? It is here it was distance upon time.
Now
Okay.
it's displacement.
Yes, but if I want something with respect to change in position, because from year to year, whatever that was, I called it as displacement. So velocity is displacement upon time. And in case the way we define this, since what is this thing? It is time. Okay, and what is this? Again, time. And we say speed is nothing but rate at which we are covering the distance. Rate, what does rate mean? कितना fast है, कितना slow, कितने time में हो रहा है. So rate at which distance is covered, that rate is called speed. And rate at which displacement, the object का displacement क्या है? We call that as velocity. Okay. So velocity is displacement upon time, and speed is distance upon time. And Arya, now can you tell me what is unit of velocity? This, like you told me, meter per second, unit of speed. Velocity का क्या होगा फिर? Displacement का ऐसा unit क्या होगा? We have
Meter.
per. If this is, yeah, good Arman, it is meter. Displacement का भी meter ही है. Distance का भी it is meter. Okay. Time again SI unit is second. So same unit, meter per second, but what is the difference? In this case, we are looking at the path at which the rate at which that path is covered, and here it is displacement. How fast is the position changing? Okay, from with respect to the initial position. Is this clear? Because we have to go further ahead of this. And I think I drew some graph, and then I drew graph with respect to showing you position is changing. Here I was plotting position versus time graph. We did this in last class. Okay, for the ones who are new, we will take that later. But I did a recap of this because today the new concept that we are going ahead with is we'll be doing acceleration. We'll be doing acceleration, okay, and we'll see uniform accelerated motion as well. And with this, we'll see uniform motion as well, and we'll try to find the difference between both of them. Okay. So Aryan was giving some formula. That formula was for acceleration. But before we go to that, you all, I know you must have not driven the car in reality, but games में तो खेला ही है. वहाँ पे accelerator भी yes, Aryan and हाँ,
Driven a car.
actual one.
Yeah. I'm a good driver.
It's strange, but please do not until you are
Yeah.
of that age. That's right. So what happens when you are moving and what happens when you put your feet on the accelerator and press the accelerator of the car? What happens? What change is seen?
When the car moves.
Moves. It was already moving. I press on accelerator. It speeds up.
It speeds.
The speed increases, right? It was moving, but then when you press the accelerator, it moves more faster, basically, you can say. And what happens if I press on brakes?
It will stop.
It will slow down. In both the cases, what is happening? My speed is changing, right? My speed is changing. So, acceleration is the concept where we see change in like speed and velocity are interchangeably used when we say that the object is moving in straight path. Like in this case, if I had taken this whole Ulta path and reached Arman, then distance would have been something else. But if I had gone from here to there, then straight from here to there, then what would have been my distance? Same as displacement. Same as displacement, right? So if path is straight, then distance and path is straight and in same direction, like in same direction, you're not changing direction as well, then distance and displacement becomes same. So we can interchangeably use speed and the term velocity. Okay? Okay. So with respect to car, and I was trying to tell you what happens when you put your when you press on brake or when you press on accelerator, what happens? It speeds up or it slows down. Okay, your speed was changing, but with respect to direction, we can also say velocity was changing because path was straight only. Like the path was straight only. So acceleration is the word used when we see change in velocity. Okay, when we see change in velocity. And again, let's say I was moving with the speed of 10 meter per second. Then press an accelerator. Speed increases to 45 meter per second. Okay. But all that happens in 10 seconds. In how many seconds?
Yes.
10 seconds. Okay. In another case, I press it so fast that that change happens in 1 second. Are you getting what my point is? In first case also there was change from 10 to 45. In second case also there was change from 10 to 45. But what was the difference? 1 second. So second one was much faster. So acceleration is change in velocity. But this change is happening in how much time? That is also important. So change in velocity upon time, that is acceleration. So whenever you see there is change in speed or velocity, when of course if it is in straight path, I'm interchangeably using it. If you are seeing change, okay, if the object is moving faster, achanak se, then becomes slower, then it is increasing or decreasing. There is change in velocity, then we say that body is accelerating. So if you see change in velocity over time, we say body is accelerating. Is this clear? And the formula is v minus u upon t. Now v and u,
Final velocity minus initial.
yes, so v is the letter for final velocity and u is initial velocity. Okay,
So, and velocity always work on a straight path.
okay, I'll answer that question. Okay, I'll come to that question. Before that, let's quickly, I'll explain what was this. It is final velocity, initial velocity upon time. Why v minus u? Because when I said my initial velocity was how much? 10 meter per second. And then I pressed on accelerator, it increased to 45. So how much is the change? Can you tell me?
45.
What did you do? 45 minus 10, final minus initial. That is why the formula comes final minus initial velocity upon time. So change in velocity is v minus u upon t. And like Aryan was asking, is it always in straight path? It is velocity. Velocity cannot change in directions. Okay. But why I was stressing on this part? Because at times you have habit of changing the word speed and velocity. I was trying to tell you the subtle difference between speed and velocity. When can you interchangeably use them? आपको समझ आ रहा है मैं क्या बोल रही हूँ? So velocity और speed ये एक दूसरे की जगह कब ले सकते हैं? जब path straight है और एक ही direction में है. तब आप इधर speed बोलो या velocity बोलो, दोनों का आंसर सेम ही होगा. ठीक है? बट अगर आपकी गाड़ी हर बारी डायरेक्शन बदल रही है तो आपके फॉर्मूले में वेलोसिटी ही रहेगा. यू कैन नॉट से स्पीड. ठीक है? बिकॉज़ यहाँ फॉर्मूला में क्या है? चेंज इन वेलोसिटी. वी आर पर्टिकुलरली टॉकिंग अबाउट चेंज इन वेलोसिटी. एक्सेलरेशन इज विद रिस्पेक्ट टू वेलोसिटी एंड ऑल ऑफ दीस आर having direction component. It is purely dependent. It is also dependent on direction. Okay? Was distance having direction component? Distance.
No.
No. What did we study for the first class? Distance versus displacement. The thing was, it is only path. How much path are you covering? 10 meter, 50 meter. You don't care about this direction. But displacement, direction is important. Why it is important? When I say from here, path is away, how much? 2 meters away from, sorry, not path, Arman is 2 meters away. But if I say, okay, Arman is 2 meters away from me, but in which direction? If this direction. So displacement, that component is very important. So Displacement has direction component. We did this. I'm stressing on it so that you do not forget. And distance is only magnitude. It's only number. Since acceleration is also change in velocity upon time, and velocity is dependent on direction, so this whole thing is also having magnitude plus direction. Is this clear? Can we take few numericals on this, and can you give me answer for acceleration? Okay. I hope you remember the formula. Take one question. Start. Is this chapter done in your school? Yes, it's going.
Same class.
Okay, same class. Is this done in your school?
Same
And
school.
students gathered.
Same school. Same school.
We all are from same school.
But it's done in your class? Okay. Same school? No. Okay. It seems you're finding it difficult to grasp, at least I'm asking. I hope by the time it is done in your school, you will be pretty good with these terms. So take the question. What is the formula? You remember what is acceleration? Acceleration is equal to?
V minus U.
What is V?
Velocity.
Which velocity? Because U is also velocity. So V represents final velocity. U represents
Initial velocity.
So take the question. I'm saying the question. Important things I'm writing. Okay. A car was moving with velocity of 40 kilometer per hour. Car was moving with this velocity. Car comes to rest, okay? It comes to rest. So this is the question. Car is moving with 40 kilometer per hour. Driver presses brake. He applies brake, and car comes to rest. In how much time does this happen? In 10 seconds. Please tell me what is the acceleration. You told me V minus U is T. So
What's
give
T?
me the answer. What is T?
Time.
Good morning. Quickly solve it and tell me, because I've given you the formula itself. You also know it. I've given you the question.
Acceleration is minus 4.
Acceleration is minus 4. Let's see if others also get the same answer. So first step should be, after if you get such question, what do we do in physics? We first find the given information, V, U and T. Tell me what all these three values are. Okay.
V is equal to 0.
V is 0.
Final position. No, but we don't know the final position.
You don't know the final
So it's
position.
0.
We don't know the final position and you decide it as 0.
No, the car is at rest, so it would be at 0 kilometers.
Okay, 0 kilometer or what is V? Velocity. So all of you are correct. Final velocity is 0 because car has what? Stopped, right? It is at rest, मतलब चलना ही बंद कर दिया है. So उसकी speed या फिर velocity क्या होगी? 0. So first answer is 0. What are the units? Kilometer per hour. Why am I asking? Because 0 kilometer.
My answer is 4.
0 kilometer per hour. U, what is initial velocity now? U value please. 40 kilometer per hour. Time is how much? 10 seconds. Okay. I gave you I should have not done this, but I'm so sorry. Take this question as it is, but answer would not be whatever you're saying. It's not that. It's good that I did this. It becomes easier. Now I'm changing. This is one question. Now I'm changing. Tell me why I changed and what I changed. Okay. So now again, V is equal to 0 meter per second. U is equal to 40 meter per second. And T is equal to 10 seconds. Okay. What did I change?
Now
You
you
change the
initial
kilometer hour into you change the time.
Okay. I changed.
Change the time, you change the initial velocity.
Did I change it? I changed the initial velocity because it's 40 meter per second. That was 40 kilometer per hour. Why did I do that? Let's see why did I do that. So first thing, let's solve this because all of you got answer 4. 4. Okay. That too for my previous question, right? So let's see if we should get 4. What is A? That I need to find. What is V? 0 minus what is U? 40. What is time? 10. Why am I able to directly put all these things? Do you know?
It was an hours and the time was.
And here this above one was meter per second. So I can directly put 10 second here because everything is in seconds. Are you getting? So what is the answer now? Minus 4. What will be my answer? This was meter per second. And again, there is another per second. We'll see how do we write this because this is
Meter per second minus.
okay. So what is he saying? This is unit for acceleration. Can somebody else
minus
also? So this is velocity, right? What is the answer about? It is change in velocity upon time. So I got meter per second above and नीचे already क्या है? फिर से second है. ठीक है? So how do we simplify this? This is meter upon second. So instead of writing this essay upon second, it is meter per second, and there was already again time. This is 1 upon time. So again 1 upon second. So there are how many seconds over here? 2. So it is meter per second square. The other way of writing this is meter. We'll bring this at top. So and we'll put negative sign meter per second square. This is the other way of writing. So the answer over here is minus 4 meter per second square. Okay. But here,
40 and
are you about to sleep? Are you sure? But in this case, can we directly put all the values? This is in hours, this is in hours, this is in. So either I have to convert these into seconds and otherwise this into hour. Which one is easier? Changing सबसे ज़्यादा will change 1. This into hour. 10 seconds means how many hours?
10
4.1
seconds.
hour.
I gave you a very complicated question, but I hope you understood
And
what.
we can change the kilometers into meters.
How will you do that? Yeah. Yes. So we can do this one.
400 meters.
Let's do that. So 40 kilometer per hour. First thing, let's change. Let's change kilometer also into meter and hour also into seconds. So this will become 40. 1 kilometer means how many meters?
40.
Upon 1 hour means how many seconds?
60.
The first one will be multiplied by 0, so this will straight away come 0 meter per second. And what is the answer for this? For 400 by 36. So it is 400 by 36 meter per second. Now you will apply this formula over here and get the answer. That is not minus 4. Okay. I hope you got what the problem is. Don't straight away jump into formula and put the numbers. Please check the units as well. Okay? Okay. I'm giving another question. This time I promise I'll not make it this tough. But then there will be some trick into that as well. Let's see, can you give me your volume? I'll give a question on your volume. Yes. Page 55. Okay, take the question. Page 163. Nobody has got me. Page 163.
163.
Yes.
Yes.
Okay, sorry. Page 172, 24. Page 172, 24. Please tell me V, U in this case and T, and they have asked you to calculate acceleration. Go through the question.
There is no question.
No, 172, 24.
Yeah, it is there.
I thought 20. Take a minute, go through the question, and then tell me what is V, what is U, and what is T, because and what is A. Have you go? And I see only 2-3 people active. What is happening? At what time do you leave from school? Look tired. All of you look tired. What happened? कितने बजे आते स्कूल से घर पे? सारे कितना? जी क्या मतलब है? मिलता है ना थोड़ा रेस्ट का टाइम. We have actually जल्दी करो. Read out the question for me, beta. I asked others of name. What about you, beta? Huh? Oh, so many Arya and Aryan.
Arya.
I understood, but Arya and Aryan. Arya or Arya?
Arya.
Arya. Arya, please read out the question. And Aryan sitting next to you will tell me what is VUT from that. Read Arya.
A body starts from rest and attains a velocity of 10 meters second.
Is it written something like this? ms -1. So what does -1 means? The other way of writing 1 upon s is s raised to -1. So it is meter per second. We say meter per second. Okay.
In 5 seconds, then it is brought to rest. In the next 10 seconds, calculate the acceleration of the body in each case.
So in each case, okay. So they have asked us to calculate acceleration for sure. So I'm putting question mark over there. So can Aryan tell us what is VUT for each case?
When the rest is 10 each second.
Can we go for first case? So first case is body starts from rest. Body starts from rest. 0. What is 0? This is 0, this is 0, this is 0.
U.
Initial velocity is 0. This is first case. Okay, first case. 0 what?
Meter per
0
second.
meter per second.
Then what happens?
It starts.
And it starts from rest and attains a velocity of 10 meter per second. So how much it is? A 10 in the velocity.
10 meter per
So what
second.
is 10 meter per second in this case?
Velocity. V.
Final. Don't say V. Okay, it's final velocity. So how much it is?
What is that -1 over there?
There.
1/s is 11.
I already told you something like this -1. I just told you that the other way of writing this is meter per second. Per is nothing but meter. It is in denominator. The other way of writing this is s upon -1. And what if I write it as ms-2?
It's
What does this mean? Meter per second square. Okay, and of course this is unit of acceleration which will come over here. Okay, Arman. Okay, so we read this as meter per second. Let me start writing this so that you get used to this thing. Okay. U is 0 meter per second. V is 10 meter per second. And in how much time does it?
5
5 seconds.
Everything is in same thing.
yes.
We can straight away put that in
Yes,
formula.
yes.
Quickly give me the answer.
And 2.
2, 1 has given. Let me see if I am faster than the rest now. Do it neatly, please.
And answer is 2.
2.
2 what?
And square.
Meter per second. Okay. So
Y square.
y square. Because what was the formula for acceleration? What was the formula for acceleration? V minus u upon t. This is what velocity. So if it is
Final initial velocity.
so what units will come? What is the unit of velocity? Unit of velocity?
Meter
Yeah, meter
per second.
per second. What is unit of time?
Second.
So upon second. So how many seconds are there in denominator? So this is also in denominator because if I write this properly, it is meter per second. And this is also already in denominator. So how many s? Where are they? Below. I can bring them up by putting minus sign. So meter per second square. Okay. Now this was for the first part. What happens in second part now?
It goes to rest.
It goes to rest again
In 10 seconds.
in 10 seconds now. So now from here, so now what was the case? From 0 to 10 meter per second, it was this. And then it again comes to rest. But how much time here it took? 5 seconds. And here how much? So now for second case, quickly tell me the answers. Quickly for second case now. I am not using it. So this first case is done. Now for the second case. Second case is which one? From 10, we'll take this second case. Can you tell us what is, okay, let her solve, she's solved. Arman, you have to solve it. Aryan, solve it. This one I'll be checking all the books. I want the answer for the second
And
one.
acceleration is 0.
Acceleration is 0. Strange, okay. Okay.
And in this case, initial velocity will be 10 meters per second.
Okay, because we are taking this.
Ma'am, my answer is 1.
Your answer is 1. Okay.
1 meter.
1 meter per second. Spell you mean? Okay.
Yes, ma'am, my answer is 5.
1. What about others? Can we have answers from you as well if you are done? We'll take answers from her now. Beta, can you tell us what is VUT value at least?
Yes, ma'am. V is 0.
So here in this case, second case, final velocity is 0. Okay, taken. What is initial velocity?
Yes.
10 meter per second. Did you say the same thing? Okay. What is T in this case?
5.
10. It's also 10.
That is 10 as well. Formula is V minus U upon T. Yes, so this is 0 minus 10 upon 10. So answer is
minus 1
minus 10 upon 10. That is minus 1 meter per second square. Okay. Answer is minus 1. Okay. Now, if you see in first case, speed increases from, sorry, let me use the word velocity. So velocity increases from 0 to 10. And when velocity was increasing, we got our acceleration as positive, right? What was our answer? Plus 2 meter per second square, right? But in this case, when velocity was decreasing, our answer comes in negative. So you get the point that whenever velocity is decreasing, acceleration should be
Increase.
decreasing.
what I'm saying is whenever velocity is whenever velocity is increasing,
Acceleration will
so acceleration, no, well, I'm just talking in terms of answer. Acceleration remains positive. But आपकी velocity जब कम होती जाती है, तो what kind of answer do you get? Negative acceleration. So if somebody asks, what is negative acceleration? So what is negative acceleration?
when the velocity decreases
Over time. Okay, because time के अनुसार ही हम मान करते हैं. Everything is with respect to time. So when acceleration is, I'm so sorry, when velocity is decreasing, we have negative acceleration, and the other name for negative acceleration is deceleration. What is the other name? Deceleration. Deceleration. The other name for negative acceleration. Is this clear? Unit, SI unit for acceleration is clear?
yes.
Only one person is saying yes.
Yes, ma'am.
Now, the target of mine was that I want to cover this too as well. It seems difficult, but let me see what I can do with this. Can I erase this?
Yes, ma'am.
So now we are doing, we did this in last class as well, but let's take a recap because then we'll have to check with respect to something called uniform motion and yes, non-uniform motion as well, and uniform accelerated motion. And there's something called non-uniform motion and non-uniform acceleration. Okay, we did this in last class. Did we? I think so. We did, no? Okay, so we'll, as of now, we'll only try to finish this, no? Okay. So what is the meaning of this word uniform? Can you tell me? It is coming in both of them. Uniform. Uniform.
Stable.
Oh, yes, stable, constant. I think this was there in this class. Just tell me if it was. If I say, okay, everybody in this room has uniform height, or all tables are of uniform height, what does that mean?
Same height.
They all have same height, constant height. Okay. So in this case, in this motion, something is remaining same, or I can say constant, right? Something. We'll discuss what. In this case also, there is something which is remaining same or constant. It is very actually easy also to know in this case what is same. Next is what accelerated. So in this case, acceleration remains constant. Okay. And in this case also something remains constant. We'll see what is. We'll see. We'll discuss in depth. So uniform motion is when an object is covering equal distance in equal interval of time. Okay, so let's say I start walking. I start walking from point A. Okay, in first second, I cover 2 meter. How much? 2 meter. In second, so this is first second. In next second, I cover 3 meter. In another next second, I cover 5 meter. So this is also next 1 second. This is next 1 second. So in this is 1 second, but I've covered this much. So in 1 second, here I'm covering 2. In next second, I covered more. In next second, I covered even more. So in this equal interval of time, it's like 1 second, 1 second, 1 second. Am I covering equal distances? No. So by this definition, do you think this motion is uniform motion? No. Why? Because it is not covering equal distance in equal interval of time. But what if I am covering, let's say something like this. In first second, this is another plus 1. This is another next 1 second. I covered 2 meter. In next second also I covered 2 meter. In next second also I covered 2 meter. What kind of motion is this now? Uniform. Why? Because it is covering equal distance in equal interval of time. Okay, so this is uniform motion. And of course, then what will we call this? Non-uniform motion. Okay, this is uniform motion. This is non-uniform motion. The other way graphical representation of this is, if I'm drawing graph, it's very important. Okay, please pay attention. Please pay attention. In graph, this is distance and this is time. We saw plotting of time and distance graph. We had some questions also in previous classes. We did solve it. So for uniform motion, where equal distance is covered in every equal interval, how will the graph look? So let's say this is time is increasing like this. So this is 1 second, 2 second, 3 second, 4 second, 5 second. So in first second, how much did it cover? This is uniform motion. So I'm capturing this one. In first second, it covered how much? Let's say this is 2, this is 4, then this is 6, this is 8. Likewise, it is increasing. So how will, if I'm representing this motion in graph, how will it look? Yes, it will look straight line. How, if I'm plotting properly, in first second, where will I plot? You're done plotting, right? So it is 2 meter. In 1 second, it is covering 2. The next one will be 4, then 6, and then 8, right? 2 plus 2, 4. Now it has covered 4. So like this, I'm plotting and I see a straight line. I'm so sorry I was not able to plot on this point, but all those points will be here. Okay. So we see that uniform motion graph will look like this, a straight line of distance versus time. This is very important. What kind of graph am I plotting? Distance versus time. It will look straight line. But if distance covered is not same, like in initial 2 seconds this much, then like this, then again something. Am I covering equal distance in every equal interval of time? So what kind of motion is this? Non-uniform motion. Is this clear? The graph part? I think we have. I will not be able to do this part, so I'll go further ahead in this. Let's see the other types of graphs. So this is equal distance, equal interval of time. Okay. The other way to say this, when you're covering equal distance in equal interval of time, okay, if I'm covering equal distance in equal interval of time, then what happens is my speed, I can say speed is constant. Okay, my speed is what? Constant. Because अगर आपकी गाड़ी 20 किलोमीटर पर आवर की स्पीड से जा रही है तो हर घंटे कितना कवर करेगी? 20 किलोमीटर, क्योंकि वही स्पीड रहेगी, राइट? और उसका मतलब वही है कि वो हर एक घंटे में कितना कवर करने वाली है? 20 किलोमीटर, 20 किलोमीटर, 20 किलोमीटर. Yeah, so every hour it is same. So basically, this is one way of saying why I am written this part, because if you are plotting distance versus time, you should understand what it means. And the other way to say is if speed is constant, right? गाड़ी एक ही स्पीड से चल रही है, मतलब वो उतना ही डिस्टेंस हर एक टाइम इंटरवल में कवर करेगी. then also our motion is called uniform motion. So if I'm trying to make a graph of speed versus time, so how will this look? What did I say? Speed क्या रहेगी? इस uniform motion में speed क्या रहती है? Constant रहती है. So I am showing two graphs. You will tell me which one is the graph which represents which do you think? I have already given the hint. Speed is constant. If speed remains same, आपकी गाड़ी same speed से जा रही है तो uniform motion रहेगा. In this second one is representing uniform motion by because यहाँ speed अगर 20 लिखा होता तो हमेशा आगे time जा रहा है but speed क्या है? Same ही है. This is which kind of motion?
Uniform.
Then this is which kind of motion?
Non-uniform.
Okay. Why? Because velocity is changing or speed is changing. Okay. Is this clear? I'll take a quick recap because time is done. And in next class, we will be doing uniform accelerated motions, graphs respect to that. Please, it's a humble request, go through the chapter so that we do not keep repeating revision of what is done. Because until and unless you understand this part, we can't go ahead. And we have to do a lot of graph part. Understanding graph depends on the understanding of concept. Okay. Aryan, is this your first class, beta? No, Aryan, the other Aryan. Is this your first class? This is your first class.
Yes, ma'am. My also first.
This is your first class. Okay. Quick recap, please.
I came yesterday, but this is the first class.
Okay. Okay. Quick recap, please. Okay, we'll start with you. Can you tell me formula for velocity?
Yeah, v minus u upon.
Is she correct? Formula for velocity. Is she
V
correct?
minus
v minus u.
It's not final velocity minus initial velocity upon time.
Anirudh, is he correct? Formula for velocity, not formula for acceleration. All of you gave me formula. What is happening? Now we'll go back to her formula for velocity.
Displacement upon time.
Is she correct?
Displacement upon time.
Formula for velocity.
No.
It's okay. Think. It's okay. Why to stress? It's okay.
Displacement upon time meter per second.
So she's correct. She said yes. She's correct? Okay, okay. She's correct. It's displacement upon time. Formula for speed, please.
Me?
No. Anirudh.
Sorry.
Sorry. Aryan.
Displacement upon time.
Displacement upon time is what? Yes, formula for?
Ma'am,
For? Yes.
for velocity and for speed it is distance upon time.
Okay, it is distance upon time for speed. And start. Okay, Aryan, can you tell us formula for acceleration, please?
Final velocity minus initial velocity upon time.
Thank you. Anirudh, can you tell us unit, SI unit for acceleration? Meter per second is unit of what?
Velocity.
Either velocity or speed, because both are same. But it's not acceleration. What is formula for acceleration?
Meter upon square s square.
Meter per second square. Okay. Okay. Can you tell me what kind of graph, or tell me what does uniform motion mean? Only uniform motion.
Uniform motion means a body that covers equal distance in equal interval of time.
What kind of graph we'll have if I'm plotting distance upon time for uniform motion?
We will have the point where it has same distance and time.
So how will it look like this or like this? Like three options I'm given, okay? For uniform motion, this is distance, this is time. Will it look like, will it be straight parallel line to t-axis? Will it be something like this straight line slant mein? or will it be third one? This. Which color? Black color, green color, or red color for uniform motion? Green color, okay. Aryan, red color. Aryan, red color.
Blue.
Where is blue? Where is blue? Anil, which color?
Ma'am, red.
Red. Red. Yes, distance versus time, it is red. Why it is red? Because equal distance is covered in equal time interval. We have straight time. Here you can clearly see distance पहले इतना था, फिर अचानक इतना हुआ, फिर अचानक हुआ. Distance covered तो same है ही, ठीक है? बदल ही रहा है. So it is this line, straight line. Okay. Please go through it. I want you all to go write notes as well, so that in next class we can quickly take a recap to the mathematical. Okay, thank you so much.
Blue color right.
Blue. Let's hold the
भाई green color का तो ये right spot. तूने दिया क्या?
कौन से दिमाग में कैसा? वैसे पीछे